Okay, can you guys all see my screen? Can you all see my screen?
I can.
All right, thank you. We'll continue where you guys ended with Prof. So today's section will cover the application of differentiation. And after today's class, you have to be able to explain the concepts of average and marginal revenue and cost. And you should be able to use the differentiation to optimize economic functions like revenue, cost, and profits functions. And the third one, use the differentiation to determine and interpret point of elasticity and linear equations. Okay, I'm just going to get and to open my camera. Can you guys still see my screen?
Yes.
Yes.
All right, thank you. If you feel that I'm fast, please don't be shy to stop me or ask me to repeat. That's fine. And if you can't hear me, please feel free to unmute your mic and tell me. Okay, as I said, the objectives for this this section would be to explain the concepts of revenue, marginal revenue and cost, and the average revenue. And you should be able to use the differentiation to optimize economic functions like revenue, cost, and profit, and use differentiation to determine and interpret points of elasticity and nonlinear. Okay, remember that your last session, which was chapter 5, was based on differentiation. So now we'll use what we learned in chapter 5. In fact, we'll be applying what we learned in chapter 5. Yeah. So we are only doing the applications today. Okay, starting from marginal and average function. Okay, we'll start from marginal and average functions. Okay, as I said in the previous chapter, the derivative of you were introduced to derivatives, right? And the derivative of a function was introduced as the equation for a rate of change and the function, right? Okay, so in economics, the rate of which the total revenue changes is called the marginal revenue, and the rate at which the total cost changes is called the marginal cost, right? Okay, he said the derivative of a function was introduced as the equation for a rate of change of the function, right? And now, this chapter, I told that the total revenue changes is called the marginal revenue, and the rate at which the total cost changes is called the marginal cost. Okay, meaning if we differentiate the marginal revenue, okay, the marginal revenue is the derivative of the total revenue with respect to Q. right, which is the output. Meaning the marginal revenue is the rate of change of total revenue per unit increase in outputs, right? This means to calculate the marginal revenue, you need to differentiate the total revenue with respect to the demand, right? That's what it means with this equation. Okay, and again, we said the marginal cost is the derivative of the total cost with respect to the output, which is the demand. Meaning the marginal cost is the rate of change of total cost in units with respect to the output, which is Q in this case. Meaning if we differentiate the total cost function with respect to Q, you will get the marginal cost. Okay, going back to the marginal revenue. Okay, the marginal revenue is the additional income that's generated from the sales in one more unit or a goods or service, right? And another thing that you need to know about the marginal revenue is that marginal revenue it is the increase in the revenue that results from a sale of one additional unit of output, right? Like if we analyze the marginal revenue, that will help us or the company to identify the revenue generated from each additional unit sold. And knowing the marginal revenue will help the company understand the demand for a product in the market, right? Let's say we are given the demand function as P is equal to A minus BQ. Remember this equation in chapter 1, right? Okay, it's chapter 2. Okay, suppose we are given that the demand for a certain function for a certain product is equal to A minus BQ. Remember that A and B are the constant, right? Okay, then from this we can find that the total function, okay, okay, first we are given that the demand function for a certain product is given as A minus BQ, right? From this we can find the total revenue function. Okay, now remember, going back to chapter 2, we found that the total revenue is equal to the demand function multiplied by Q, right? So it's P times Q. So it's the demand function multiplied by the number of units demanded, right? Okay, it's PQ, where, yes? Okay, I thought someone was saying something. Where P is given by this function, right? So we have B, A minus BQ times Q, which is AQ minus BQ squared, right? Okay, this is our total revenue. So if you are given a demand function, from the demand function you can find the total revenue by multiplying a total revenue by a number of units demanded. Okay. Now we have a total revenue, right? from the total revenue, what can we find? Remember, for now, we're talking about the marginal revenue, right? And we were told that the marginal revenue is the derivative of the total revenue with respect to Q, right? And here we were given the demand function, right? From the demand function, we multiply the demand function with the number of units demanded, and we obtained the total revenue. What can we do from the total revenue to get the marginal revenue, right? Remember that the marginal revenue function is the derivative of the total revenue, right? So this means marginal revenue in this case would be, okay, the derivative of the total revenue with respect to Q. And our total revenue in this case is AQ minus BQ squared. And we're differentiating with respect to Q, right? And you did derivative in your last section, which is chapter 5. Okay. So we differentiate, okay, we have to differentiate this function with respect to Q. If you differentiate AQ, what do we get? The derivative of AQ with respect to Q. All right, say we differentiate AQ with respect to Q. And remember that A and B are the constant, right? So this means if we differentiate, okay, let me just separate it like this. Remember, if you differentiate AQ with respect to Q, we'll get the constant, right? And if we differentiate BQ squared with respect to Q, we'll get minus 2BQ, right? So this means our marginal revenue in this case is A minus 2BQ. Do we have questions for now?
The 2P, how did we find the 2P?
Okay. Remember, in the last chapter, if you're given, let's say, if you were told that f at x is equal to a x n, then this means the derivative of f at x, okay, which is the derivative of f with respect to x would be, you'll take this power and multiply it by a constant, right? By this coefficient. So this means we'll have a times n, right? And then you'll have x, then you subtract 1 from the power. So this means you have a times n x to the power n minus 1. So this means the derivative of f with respect to x is a x n minus 1, right? Going back to this function, our, okay, let me just put it as f at q. Our f at q in this case was bq Q squared, right? And we were asked to differentiate F with respect to Q, meaning is the derivative of F with respect to Q, right? We said we have to take the power and multiply it by a coefficient. So this means we have B times 2Q, then we subtract 1 from the power, right? Are we all still together? So this means we have B times 2, which is 2B, Q to the power 2 minus 1, which is Q, right? Which is Q to the power 1, which is the same thing as 2BQ, right?
Yes.
Do you understand now?
Yes.
Right.
Yes.
Okay. Do we have any more questions? Can we move on?
Yes, we can.
All right. Thank you. Okay. Let's do an example. Okay. Now, suppose that you are given a demand function as P is equal to 10 minus 0.3. Right. We are given this as the demand function, and we are asked to find the marginal revenue. Okay. We are given a demand function, and the question says you should determine the marginal revenue. Okay. First, we said the marginal revenue is the derivative of the total revenue with respect to Q, right? But we don't know the total revenue yet. But you can find the total revenue by multiplying the demand function by the number of units demanded, right? So, okay, we said the total revenue is equal to the demand function times the number of units demanded, right? And we know that the demand function is, okay, we are given the demand function. So this means we have 10 minus 0.3 Q times the number of units demanded. Okay? So this means our total revenue in this case will be 10Q minus 0.3 Q squared, right? This is our total revenue, but we don't have to end. Okay, we don't have to end here because we are asked to find the marginal revenue, not just the total revenue. The reason we first calculated the total revenue is because we wanted to find the marginal revenue. Remember, that's the marginal revenue. We said it is the derivative of the total revenue with respect to Q, right? So since now we have the total revenue, you can be able to find the marginal revenue. So we have the marginal revenue as the derivative of the total revenue, and our total revenue, we know it's 10Q minus 0.3 Q squared, right? Okay, we are differentiating with respect to Q. Okay. Let me separate it again. 10Q with respect to Q minus the derivative of 0.3 Q squared with respect to Q, right? Okay. You can take out the coefficient outside the derivative. like you can say this is equal to 10, the derivative of Q with respect to Q, right? Because we take out this 10 to the side. And again, here we can take out this 0.3. So we have minus 0.3, the derivative of Q squared with respect to Q, right? So now we have marginal revenue is equal to 10, the derivative of Q with respect to Q, minus 0.3, the derivative of Q squared with respect to Q. Okay, this means we have 10 times. What do you get if you differentiate Q with respect to Q? Anyone?
Can you come again, please, ma'am?
What do you get when you differentiate Q with respect to Q?
Don't they
It's
cancel?
1.
It's like, okay.
Isn't it
like
1?
Yes, it is 1, right? Then minus, we have 0.3. What is the derivative of Q squared with respect to Q? If you differentiate Q squared with respect to Q?
Q is Q.
It's 2Q, right? So this means our marginal revenue in this case is equal to 10 minus 0.6 Q, right? Are we all still together?
Yes, ma'am.
Yes, ma'am.
The 2Q, it's a bit confusing for me because what I did here, okay, I was using a calculator, or maybe it doesn't apply. So I said 1 squared divided by 1, it gave me 1. So how do we get 2?
Okay. Remember, this is the same thing as, let's say you are given f at x is equal to x squared, right? And you are asked to find the derivative of f at x, meaning you are asked to find f prime at x, right? F prime at x is the same thing as the derivative of f with respect to x, right? Which is in this case, remember, you take 2, you multiply by a coefficient. Our coefficient is 1 here, right? So this means we have 2 times 1, then x, then you minus 1 from the power. So we have 2 minus 1, right? So this means we have 2x. That's why we have 2q.
Oh, I keep
This is just the power rule.
Oh no, now I see my mistake. I keep on forgetting I'm multiplying the coefficient. Now I see how we got 2.
Oh, all right, no problem. Can we move on?
Yes.
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 Right. Now, we have marginal revenue is in 10 minus 0.6. This is the marginal revenue function. Okay. From the marginal revenue, we can find what would be the next, like, unit sold. Yeah. Okay, let's say suppose you are told that see first. Okay, let's say we want to find when would be, let's say 10 units sold, or after 10 units sold, what would be our marginal revenue, right? Okay. We have the marginal revenue function, and we want to find the marginal revenue units sold after a certain number of units have been sold. Let's say we are given that 10 units have been sold, and we want to find the marginal revenue after 10 units, right? So in that case, this means, okay, in this case, this means Q is equal to 10, right? We are told that, okay, we are asked to find the marginal revenue after 10 units have been sold. I want to find the marginal revenue at Q is equal to 11, right? So this means we have to substitute this Q in our marginal revenue. Okay, this is our marginal revenue, 0.6 times 10, right? If 0.6 times 10, so this means we have 10 minus 6, which is 4, right? So this means the 11th unit will cost, will add an additional income of 4 rand, right? This means the 11th unit will add an income of 4 rand, right? Now I think, let's say we are asked, the additional income after the 15th unit. If we are asked that questions, that means we'll use our Q as in 15, right? Because they said we should find an additional income after the 15th unit, meaning when we sell the 16th, after 16th units have been sold, what would be the additional income, right? So in that case, for marginal revenue, we'll have 10 minus 0.6 times 15, right? This is 10 minus 9, which is 1, right? If Q is equal to, okay, if Q as in our unit is equal to 15, that means the additional units, the additional income after the 16th unit would be 1 rand. It's just 1. Do we have questions for now?
If we were given quantity instead of price, how would we work around that? Is it the same way?
Yes, it's the same way. Okay, that's how you find the marginal revenue. Okay, let's try and move on to the marginal cost. Okay, guys, the marginal cost. Remember, this is just the increase or decrease in the cost of producing one more unit or saving one more customer. Ne? And the reason we have to know how to calculate the marginal cost is because the advantage of knowing the marginal cost is that it helps a company understand when it's no longer profitable to manufacture an additional goods, right? The marginal cost, yes, it will help the company to understand when its profit is no longer profitable to manufacture or produce more goods. And another thing, a company's marginal cost is how much extra it is to produce additional units or goods service or goods or service. Yeah, I hope that makes sense. Let's say, for example, consider a company sells phones for 5,000 rand, right? And it says an additional capacity to manufacture more phones, and let's say it's approached, and it is given an offer to buy 100,000 phones for 4,000 each, right? Okay. A company sells phones for 5,000 rand, right? And it has additional capacity to manufacture more phones. And now another company approaches it, and it gives that company A an offer to purchase like 100,000 phones for 4,000. That's like if they buy those phones, in each phone they will make a profit of 1,000 rand, right? Now, a marginal cost will help a company decide whether it makes sense to accept that offer or not. Because sometimes, let's say, they buy these 100,000 phones, and let's say maybe they sell only 500,000, only 500 phones, right? That means they've lost, because it's like they wasted, they bought something which they won't be able to sell, right? So if a company knows how to calculate the marginal cost, then that means it will save their profit in the business. Okay, remember that the total cost, it consists of the fixed cost plus the variable cost, right? And then the marginal cost is found by differentiating this total cost with respect to Q. So this means the marginal cost is equal to the derivative of a total cost with respect to Q, right? So this is the same thing as the derivative. We use a sum rule, the derivative of, okay, remember the total cost is FC plus VC, right? So the derivative of FC, which is the fixed cost, plus variable cost, right? And with respect to Q, if we use the sum rule, we have the derivative of the fixed cost with respect to Q plus the derivative of variable cost with respect to Q, right? But remember that the fixed cost is constant, right? And we know that the derivative of a constant is 0, right? So this means the marginal cost is equal to the derivative of the variable cost with respect to Q. Since the derivative of the fixed cost is equal to 0, because the fixed cost is a constant, and we know that the derivative of a constant is 0. Right, so we can use this formula to find the marginal cost. So this means we'll differentiate the variable cost with respect to Q. Right. Okay, for example, let's say we are given that the total cost is equal to 1,000 Rand plus 35 Q, right? If we look at this this total cost, we can simply tell that here the fixed cost is equal to 1,000 Rand, right? And the variable cost is equal to 35 Q, right? Okay. We are given this as the total cost, and we are asked to find the marginal cost. And we said the marginal cost, okay, let's start here. I want to show you how do we, like, just making an example. Why do we say the marginal cost is just the derivative of the variable cost with respect to Q instead of the derivative of a fixed cost plus the derivative of variable cost, right? Okay, I will use this one, which is the marginal cost is equal to the derivative of the total cost, right, with respect to Q. Okay, our total cost is 1,000 plus 35 Q, right? So this means we have the derivative of 1,000 plus 35 Q with respect to Q, right? Which is the same thing as the derivative of 1,000 with respect to Q plus the derivative of 35 Q with respect to Q, right? Okay, the derivative of 1,000 with respect to Q, remember 1,000 is just a constant, right? And we said a derivative of a constant is 0. So we have 0 plus the derivative of 35 Q with respect to Q. And we know that the derivative of 35 Q is equal to 35, right? And this is the derivative. Okay, we said 35 Q is the variable cost, right? So you see that at the end, the marginal cost is just the derivative of the variable cost only.
Yes.
Right. So rather than using this formula, the derivative of the derivative of a total cost with respect to Q, you can just say the marginal cost is the derivative of the variable cost with respect to Q. It's the same thing at the end. Okay. Do we have questions? No? Yes, no?
No, ma'am, we're following.
All right, thank you. Okay, here we were asked to find marginal cost, and we say the marginal cost is equal to 35, right? 35. Okay, this means that the marginal cost does not vary with the outputs since it is just a constant, right? Meaning it does not depend on the outputs. Let's try and do another example. Example 3. Suppose now we are given our total cost is 1/2 q squared plus 100 q, and we are asked to find marginal cost, right? If we look at this total cost, you can tell that the fixed cost is equal to 0 in this case, and the variable cost is equal to 1/2 q squared plus 1000 q, right? So this means our marginal cost in this case would be the derivative of 1/2 q squared plus 100 q with respect to q is equal to, okay, it will be q plus 100. Yeah? So this is our marginal cost in this case. If we are given that the total revenue, the total cost is this, right? Okay, so this simply means, let's say we are told that the output, okay, Q is 10, right? The demand is 10. What does that mean? Okay, say we are told that Q is 10. If Q is 10, this means our marginal cost would be, okay, we substitute 10 where there is Q plus, okay, these hundreds we have 110. Okay, so this means that the cost to produce the 11th unit is 110, right? Because here our Q is 10, so that means the next unit here will be 11, right? That will be the 11th unit. So if Q is 10, that means the marginal revenue is 110, and if the marginal revenue is 10, it is 110. That means the cost to produce the 11th unit is 110. Right. Are we still all together?
I have a question.
Yes.
Okay, you see there where we said where you said marginal cost is equals to a derivative of 1/2 blah blah blah.
Yes.
So I understand the left-hand side because you said a derivative of, I forgot how you put it, but of a fixed cost is 0. So I get that. So that means we are left with 100 Q. So I just want to understand how, if the Q comes to the left-hand side, we then say plus, we don't say times.
Yeah.
I'm not sure if I'm making sense because I understand the fixed cost part. My question is on the right where we have 100 Q.
Yes.
because then you came with the answer that says the marginal cost is Q plus 100. I just want to understand how we got that Q plus 100, because I see 100 times Q there at the top.
Okay, back to the previous chapter. F
Or
of
maybe
x
because I missed
is
the
equal
last
to
class.
A xn, right, plus B xm. Suppose we are given a function like this, and we also find its derivative, meaning we are also find the derivative of f with respect to x, right? Again, you take the power and you multiply by a coefficient. So this means we have a times n and x to the power. You subtract 1 from the power, right? So this means we have x to the power n minus 1, right? Plus, again, here it's you take the power, you multiply the coefficient, right? So this means we have b times m x to the power, you subtract 1, right? So it means we have m minus 1, right? Okay.
Yes.
Going back to this equation, right?
Yes.
That equation is MC is equal to 1 over 2 Q 2 was it plus 100 Q, right? If we
Yes.
compare these two equations, okay, it's this and this one, right? F at x is equal to A xn plus B xn. Did you guys do differentiation with Prof?
Yes, ma'am, we did.
Yes.
Yes,
No, I
we
don't
did.
remember.
All right, thank you. If we compare
Yeah,
these
some of us who
two,
couldn't join the
if we compare these two equations, right, this means A is equal to half in this case, and N is equal to 2, right? Do we all agree? And B is equal to 100, and M is equal to 1, right? And we said if we are given f at x, like as in this equation, this means the derivative of f at x would be this, right? Which is would be f at, the derivative of f at x with respect to x would be n a n next to the power n minus 1 plus b m x to the power m minus 1, right? So what we'll do here, because we said a is equal to half, we'll go back to this equation. Where we see a, we'll put half. Where we see n, we'll put 2. Where we see b, we'll put 100, and m, we put 1, right? So this means our derivative is 1 over 2 times 2 x to the power 2 minus 1 plus 100 times 1 x to the power 1 minus 1, right? So this means is half times 2. Half times 2 is 1, right? So we have 1 x to the power, we have 2 minus 1. 2 minus 1 is 1, right? So it's to the power 1. Plus we have 100 times 1 is 100, right? And we have x to the power 0, right? Going back to the laws of exponent, any number besides 0, any number to the power 0 is equal to 1, right? So where there is, this means where there is x, we can substitute x with 1, right? So this means our derivative of f with respect to x is equal to x plus 100, right?
Yes, I'm following.
That's why we have q plus 100, because
Okay.
q plus 100 is the derivative of this function with respect to q.
Okay, I get it.
You sure you do understand?
I do, I'm sure.
Right. Can we move on?
Yes.
Our next topic is the average revenue in the cost function. Okay, the average functions give expressions of the average value of economic variables over an interval. Okay, the average revenue, it is the revenue per unit of output. And another thing, the average revenue helps in estimating the profits of a business, as the profit is calculated by subtracting the average revenue from the average cost. Okay, this is the formula that we'll use to calculate the average revenue. Average revenue is the total revenue divided by Q, right? Okay, from this formula, we can find that, okay, we can solve for total revenue from this formula, right? We have average revenue is equal to total revenue over Q. And here we want to make the total revenue the subject of the formula, meaning we want to be left with the total revenue in one side only. And to cancel the total revenue, we can multiply with Q on both sides, right? So as we do this side, we have to do it on this side. And if we multiply with Q on both sides, Q and Q will cancel this side and we'll be left with total revenue. And total revenue would be average revenue multiplied by Q, right? Average revenue multiplied by Q. Okay. Remember that the total revenue is equal to the demand function times the number of the units demanded, right? So we have the total revenue is equal to the average revenue times Q, and we know that the total revenue is equal to PQ. So what we can do is in this equation where we see a total revenue, we can substitute that with this PQ, right? And if we do that, we'll have something like this. Average revenue times Q is equal to P times Q, right? Let's say we want to make the average revenue the subject of the formula. We want to get rid of this Q, this side. If we want to get rid of this Q, the easy way is to divide with it on both sides, right? And if we divide with it on both sides, we'll have average revenue. Q and Q will cancel out, right? And here, Q and Q will cancel out. This means the average revenue is equal to P, right? So this means the average revenue is equal to the price, whereby the price is given by the demand function, right? Because remember, in the total revenue, this price is given by the demand function. So we can use this formula to find the average revenue. And we can use the demand function to find the average revenue. And that's the average cost and average revenue and the average cost. Okay, let's move on to the average cost. Okay, all production cost divided by the quantity of output produced. Knowing this cost will help in making pricing decision, because any price below the average cost will result in financial loss. Mathematically, we can use this. We can calculate the average cost, then total cost divided by the quantity of output, which is Q, right? Okay. From these equations, it follows that the average cost is then the cost that is given by the average cost multiplied by the number of units produced. The total cost, okay? The total cost is equal to the average cost times the number of units produced. So this means we can use this formula to find the total cost too. Okay. We have this formula to find the average cost, and we have this formula to find the total cost, or the average. Oh, this one is the average revenue, and this is the average cost, right? Now, suppose we are given that the demand function for any company or for a monopolist is given by P is equal to 300 minus 2Q, right? Okay. If we are given a demand function, we can find the total revenue, we can find the average cost, we can find the average revenue, can find the average cost or the total cost, right? Okay. From these, the total revenue would be, remember, it is the demand function times the number of units produced or required, right? So this means the total revenue in this case would be 300 minus 12Q times Q, right? This means our total revenue would be 300Q minus 12Q squared, right? Okay. Remember our first section today was to find the marginal revenue, right? And we said the marginal revenue is the derivative of the total revenue with respect to Q, right? And the total revenue in this case is this. So this means our marginal revenue will be the derivative of 300 Q squared over T with respect to Q. And this means our marginal revenue in this case is equal to 300 minus 24Q. Okay, meaning if we are given the demand function, we can also find the marginal revenue. Okay, what else can we find if we are given the marginal? Okay, now we have the demand function and the marginal revenue. What else can we find from what we did today if we are given these two equations? Can we find the average cost? Remember, we said the average cost is equal to the marginal revenue over Q, right? And we have the marginal revenue and we know Q. Now this is the average.
Shouldn't it be TC?
It is. In fact, is supposed to be.
Shouldn't it be TC over Q?
It's supposed to be T. What is this? It's supposed to be TR over
TR, sorry.
STR over Q. And our TR is, in this case, 300Q minus 12Q squared, okay, over Q. So this means our average cost is equal to 300 minus 12Q. Okay, now we have the demand function, we have the total revenue, and we have marginal revenue, and we have the average revenue. What else can we find from this information? Do we still have time?
About 17 minutes.
Okay. Let's try and do another example.
May we try one from the study guide on page 81, number 5.
I don't have the study guide open. What does it say?
It says consider the following total revenue and total cost functions of a firm. Then
Total revenue is
total revenue is equals to 200Q
200Q
minus 4Q squared.
minus 4Q squared, and
TC is equals to Q cubed
Q cubed
divided by 3 minus 12 Q squared
divided by 3 minus 12
Q squared
Q squared
plus 164 Q
plus 164 Q
plus 100.
plus 100.
Yes. And then
What is the question there?
it says derive the formula for marginal and average revenue.
For marginal revenue.
Yeah, it says, yeah, for marginal and average revenue. Marginal and average revenue.
Oh, okay, okay. So we have TR and TC, right? And we are asked to find the marginal revenue and
Average revenue.
average revenue. Okay. We know that the marginal revenue is equal to the derivative of total revenue with respect to Q, and the average revenue is equal to TQ is equal to
TR.
total revenue divided by Q. Right?
Yes.
Okay. From this, we have, okay, we can calculate marginal revenue as in the derivative of 200Q minus 4Q squared, right? And we are asked to differentiate this with respect to Q. So this means our marginal revenue would be the derivative of 200Q with respect to Q minus the derivative of 4Q squared with respect to Q, right? So this means our marginal revenue would be 200 minus 8Q. Right?
Yes.
Yes,
Okay.
that's good.
And we were asked to find
What is it?
Average revenue.
Average revenue.
oh, okay, average revenue. We said the average revenue is equal to the total revenue divided by Q. Right. So this means our average revenue is equal to the total revenue, which is 200Q minus 4Q squared divided by Q. This means our average revenue would be 200 minus 4Q, right? We're only asked to find these two.
And also the marginal and average cost, marginal cost and average cost.
Marginal cost and average cost. Okay.
I'm lost a little bit, ma'am. Where you have marginal revenue is 200 minus 4Q, and then on top there you also have marginal revenue is 200 minus 8Q.
Oh, this is average. Yes, this is an average cost. That's this one. Okay. Average cost is equal to
still the same. Is it still going to be 4 or is going to be 8 there?
No, it's remember here for an average revenue, we are dividing with Q. So this
Or
means we
dividing.
have 200 Q over Q minus 4 squared over Q. But here we were differentiating, we're not dividing.
So the marginal, is it always the case where the marginal revenue is differentiating and the average you have to divide? Is it always the case?
That's the average revenue, you divide the total revenue with Q.
Okay, thank you, ma'am.
Okay, we said we also find the marginal cost too, and the marginal cost is the derivative of the total cost, right? So we are asked to differentiate what is our total cost. 1/3 Q. Please give me the total cost again.
It's a 3 cubed divided by 3.
Minus.
The 1/3.
Okay, it's fine. I'll take it. Yeah. Minus 12 Q squared plus 164 Q plus 100.
The 1/3, how did you get it, ma'am?
We were given 1/3.
No, it's 3 cubed over 3. Oh, it's okay, I see it. It's the same as 1/3. Okay, I see it.
With respect to Q. Okay, we're differentiating with respect to Q. This means we have the derivative of 1/3 cube with respect to Q minus the derivative of 12 squared with respect to Q plus 164. Okay, the derivative of 164 Q with respect to Q plus the derivative of 100 with respect to Q. The derivative of 1/3 Q cubed is Q squared, right? And the derivative of 12 Q squared is minus 24 Q, right? And the derivative of 164 Q is plus 164. And the derivative of hundreds, remember hundreds is a constant, and the derivative of a constant is 0, right? So this means our marginal cost is equal to Q squared minus 24 Q plus 164 plus 164. Yeah. This is our marginal cost. And after the marginal cost, we will also find what?
The average cost.
Okay, the average cost.
But before we move to the average cost, can I just take you back? If you may just explain for me how we converted Q cubed divided by 3 to 1/3 Q cubed. How did you convert that?
It was 3 cubed over 3, right?
Yes.
This is the same as 1 times cubed over 3, right?
Yes.
This is like you multiplying 1/3 times 3 cubed, right? You'll get the same thing, right? Because if you multiply 1/3 times 3 cubed, it's like, okay, it's like you have 1/3 times 3 cubed over 1, right? If we are multiplying fractions, This means you have to multiply the numerators together and you multiply the denominators together, right? So this means we have 1 times q cubed over 3 times 1, right? And this is the same thing as, okay, 1 times q cubed is q cubed over 3 times 1 is 3, right?
Yes.
That's why instead of writing it like this, I just decided to write it like this because it's the same thing, they are equal.
So if it was q
So
squared, can go ahead.
sorry to interrupt. So the other thing that I've just realized, that 3 is our n. So when you drop the 3 to go and multiply it by a third, that's how it's gonna end up like that, isn't it, ma'am? If you
No,
drop the
before-
3,
yeah, I haven't differentiated here.
or you haven't differentiated yet.
Yes.
Oh, okay, all right. So I was getting it wrong there, but I was just getting the same answer. I don't know how.
You have 1 over 3 q cubed, right? Which we agree is the same thing as this one, right? After differentiating, you drop this 3, you'll have 3 times this 1 over 3 q to the power 3 minus 1, right? So we have 3 times 1 over 3, which is 1, right? And q, 3 minus 2, 3 minus 1 is 2. So this is like we have 2 squared, right? So after differentiating this, you'll have this, right? That's why here I have q squared. Is it clear? Yes, no?
Maybe.
That's not good enough.
Yeah. So maybe if it's to start from the beginning, that 1 is our constant. Like when we have x, it's 1x or it's x. That's where we're getting the 1. Am I correct?
Which one?
Like when we get like where you get the 1/3. What was our original equation?
Yes, this
Was
is our
was
original
it
equation.
Is it 3 cubed or 1/3 cubed? What was the original?
It's
Third
3
cubed.
cubed divided by 3.
It's 3 cubed divided by 3.
It's q cubed divided by 3, sorry.
So it's q cubed. That's why I'm saying in front of q already we have a 1. Am I correct, ma'am?
Yes.
Like x cubed, it's like 1x. I mean,
Yes.
yeah, yes, 1x cubed.
Yes, that's
Okay.
correct.
Okay, ma'am. Thank you.
All right, thank you. Do you have any more questions? Yes, no? Oh, okay. And we were asked to find the average cost, and we said the average cost is total cost divided by Q, right? And our total cost was 1 over 3 cubed, was it plus, minus 12 Q squared plus 164 Q plus 100 over Q, right?
Plus 164Q.
Yes, plus 164Q plus 100. And if we divide this by
Plus
Q,
100.
we should have 1/3
Yes.
Q squared
Yeah.
minus 12Q plus 164Q plus 100/Q. This is our average cost. Do we have any questions?
Even if it was in this chapter, any constant divided by we said what, Q or 0? I mean Q is 0, or it only applies in this in differentiation.
You please repeat your question again.
Any constant divided by Q is 0, or does it apply in any chapter of the study guide, or it only applies in differentiation?
A constant divided by Q is not 0. But a derivative of a constant with respect to Q is 0. Or a derivative of a constant with respect to any variable is 0. Like you are differentiating a constant, né? Let's say you are given that f at x is equal to 10. 10 is a constant, right?
Yes.
And we are asked to find the derivative of x, which is the derivative of f with respect to x, right? It's like you're differentiating f with respect to x. And your f is a constant, right? And we said the derivative of a constant is 0. Yeah?
Yes.
So it's like you are given that MC is equal to 50. Yeah? And we are asked to find the derivative of MC with respect to Q. Right? It's like you have asked to find the derivative of 50 with respect to Q. The derivative of, okay, 50 is a constant, and the derivative of a constant is 0. It doesn't matter you are differentiating with what variable. As long as you are differentiating a constant, you'll get 0.
Okay. No more questions.
Do we have any more questions?